Hi guys, and welcome back to the Python series. So in this video what we're going to talk about is a few very simple and elementary problems which will test the knowledge of whatever we have done in this series so far, right? So every question that we do here, we are not claiming that the solution I'll be giving you is the most efficient solution, because there's this thing called time complexity and space complexity. So we are not going to bother ourselves with all these details right now. So all we want is a simple, elegant code that gets the job done, all right? So without any further ado, let's get started. So the first question is, write a program to enter two numbers and check whether they are co-prime or not, right? So for this, first of all, we need to start off with entering two numbers. So let's say A is our first number. And remember we talked about this, that when we input something in Python, its default data type is string, right? So we want to convert this to an integer, right? So let's go with int of A. And similarly, we'll input another number. Let's call that B. The same code, just replace the names, right? Okay. So we have our two numbers. Now, two numbers are said to be co-prime if the GCD is 1, right? Now, technically finding the GCD is going to be slightly lengthy process, so we don't want to do that. So all we want to do is check that if these two numbers have any common divisor. Because if these numbers have any common divisors greater than 1, then we can be sure that the GCD is definitely greater than 1 and they're not co-prime, right? So that's what we'll do. So we'll start a loop for I in range, let's go with 2 all the way till A plus B. Now, why do I go tell A plus B? Because you know that A plus B is a number that's strictly greater than A and B, right? I mean, if you want to make this more elegant, you can go with the maximum of these two, but I mean, we can work with A plus B as well, right? That's an easier, more brute force method. Okay, so we start a loop and then we'll check if I divides A, or if A mod I, okay? So this is a new notation. So if A mod I equal to 0 and B mod I equal to 0. All right. So what would this do? So mod operation basically gives you the remainder when you divide one number by the other. Okay. So the integer remainder. So in this case, we are checking if A mod I equal to 0, which means we want to check if I divides A. And is a keyword which tells Python that both the conditions need to be true and only then would this if statement be true, okay? Even if one of them becomes false, the overall if statement will become false, right? So if you get a common divisor I, then what do we do? See, one thing is you can directly print over here that the numbers are not co-prime. But in case they are, how would you figure that out at the end of the loop, right? Because there is a chance that at the end of the loop, it doesn't have a common divisor, right? But we can't really go outside the loop and print that they're not co-prime, right? Then you'll get two statements. So for this, what we use is known as a flag variable, right? So f equal to 0, this is a flag variable for us. So what exactly is a flag variable? So whenever we are working with something like this, that even though there is a chance you might know in between your loop that whether this condition is true or not, but we still want to continue the entire loop. So in that case, we use a variable, and based on the value of this variable, we can decide like what is the actual outcome, right? So f equal to 0 is the initial value. What I'll do over here is, if you get a common divisor, I just change the value of f as 1, right? Now, when I come outside the loop at the end, I know that if f is equal to 1, then these two numbers are not co-prime, right? Because we change the value once we get a common divisor. So based on the value of f, I can say if f is equal to 1, I can print that the numbers are not co-prime, right? And if it's not, else, I mean, the only other alternative is that f will have a value 1, right? Else I can print, print not co-prime, and coming to the next line, we can say that else co-prime, right? So that's the idea. Okay, so if I run this code, let's see what happens. Okay, there was a missing, yeah. So there's a code, so it's asking us for the input. So input the first number, let's go with simple numbers 2 and 3, okay? So 2 and 3 are co-prime, right? So we get the output. Similarly, if I take some other numbers, let's say 17 and 18. Why am I using consecutive numbers? Because I know that they will have to be co-prime, right? So they are again co-prime. Let's go with another pair. We can go with 12 and let's say 49. These two numbers are also co-prime. Let's check for numbers which are actually not co-prime. So if I take 12 and 18, you can see that they are not co-prime, right? So this is a very simple code which just checks if two numbers are co-prime or not, all right? So that's the first one. Now let's talk about the second question. The second question is, write a program to display all the buzz numbers between P and Q, where P is something that's smaller than Q. What is a buzz number? It's a number which either ends with 7 or is divisible by 7, right? So there are two things you need to check, all right? So how do you check if a number, it's very easy, right? So let's start off with, so you want to print all the bus numbers between P and Q, right? So for I in range PQ, okay, I'll also have to input the numbers before that. So I'll do it after the statement. So let's copy this and we'll just change the names maybe. So this is P and this is Q, right? So, sorry, this will be Q, this will be P. Okay, so this is the range in which we are working. Now, so how do you check the last digit of a number? The last digit of a number is basically the remainder you get when you divide the number by 10, right? So for example, 12 mod 10 is going to give you 2, right? And 2 is the last digit of 12. So okay, we also have to input the number, okay? So n is equal to input. I mean, this is a number that oh no, we don't want to check this. So we just want to print out the numbers in this range, right? So I is the variable that we are using. So if I mod 10 equal to 7 or, so what does I mod 10 tell you? The last digit, right? So the last digit is 7 or. So or is a similar keyword to and, right? So in and we wanted both the statements to be true. But in case of or, if either one of the statements is true, then it works, right? I mean, it will be a bus number. So if I mod 7 is equal to 0, then we can say that you print this number, okay? So you print I, otherwise you don't do anything, right? I mean, only if it's a bus number we want to print that, right? So if I run this, let's put the input, let's go with 1 to 100, okay? Let's say the bus numbers. So you can see 7 is a bus number, yeah, 14, 17, 21, 27, 28, 35, 37, so on and so forth, right? So these are the bus numbers you'll get from in the range 1 to 100, right? So very simple 3-line code, okay? Cool. So this is the second question. Coming to the third one, a number is said to be a duck number if its if the digit 0 is present in it at any point, okay? Write a program to accept a number and check whether it's a duck number or not, okay? Okay. So let's start off with inputting a number. Let's go with this. So let's say A is a number that we want to check whether it's a duck number or not. Again, now, how do we do this? See, for this, we'll have to access all the digits of this number individually, right? Now, one way is you can convert it to a string and then you can basically access all the characters, see if 0 occurs anywhere or not, right? But how would you do it in terms of just numbers, okay, without converting it to a string? So for that, what we can do is while, so let's go with a while loop here, right? So while, let's define a new number B to be equal to A, and let's go with while B is not equal to 0, okay? And what do I do is, I check the last digit of a number and if it's 0, good enough for me. If not, I'll ignore that number, that digit rather, and then look at the second last digit and I keep doing this process. So how do I do it in terms of code? So if while B is not equal to 0, I'll check if the last digit of the number, let's go with B mod 10 equal to 0. Then what do I do? So again, I need a flag variable, right? Because I don't know which digit is going to give me that particular digit 0. So let fb equal to 0. This is a flag variable. So if b mod 10 is equal to 0, I change the value to 1. And otherwise, I mean, it doesn't matter, okay? Even if it's not, I want to get rid of the last digit, right? So I'll write b equal to b /10, right? What does b /10 do? It basically gives you the quotient, okay? The integer quotient when you divide this number b by 10. So for example, if you have 1, 2, 3 and you divide it by 10 or /10, you'll get 12, okay? So you're basically removing the last digit of the number. And I continue this, right? As long as b is not equal to 0. And if I come outside, if I check with f equal to 1, I'll print that it's a bus number. Otherwise, you just print not a bus number. Okay, so let's run this and see what happens. So we want to input a number. For example, let's go with 1240. Oops, sorry, 1240. And see, it's a bus number, right? So this is easy. Let's go with one number which doesn't have any zeros. So 1, 2, 3, 4, 5, 6. You can see it's not a bus number, right? Okay. So very straightforward code. So it's practically easy, okay? So this feature that we're using over here, right? Accessing the last digit, removing the last digit, this is very important. And you'll see this in the next question as well. So next question is, write a menu-driven class to accept a number from the user and check whether it's palindrome or perfect number. What is a palindrome number? A number which is the same in both the orders, right? Like from left to right and right to left. If it reads the same number, then it's a palindrome number. What's a perfect number? A perfect number is a number which is equal to the sum of the factors other than the number itself, okay? So what is a menu-driven class? It basically means that the user will give his choice, right? For example, he'll enter a number n. He'll also tell you whether he wants to check it for a palindrome number or a perfect number, right? So it sounds fancy, but it's actually not. It's very straightforward. So let's start off by inputting the number. Let's say n is the number that we're inputting. So let's paste it here. Let's go with n. Maybe simplifies things. This is n. All right. And one more input needs to be taken, which is the choice of the user, right? So let's call that C. And again, we'll do the same thing with that. So basically paste this again. So this is C, and this is also C. Right, so this is the choice of the user. Now, based on this choice, we'll have two conditions, right? If C is equal to, okay, I want to input a message over here, right? So inside input, if you write a message, that will be the message that's displayed to the user when they're inputting the number, right? So for example, if I put C equal to input, enter your choice. Let's make it fancy. Enter your choice. Let's say 1 for palindrome and 2 for perfect. Right, let's give a message something like this, okay? So if C is equal to 1, if the choice is 1, it means that the user wants to check if it's a palindrome number or not. So how do you check whether it's a palindrome number or not? You'll basically have to reverse the number, right? So for that, what we do is, let's define an empty number, define S to be 0. Then, while this number, let's also copy this number n somewhere. So let's say A is equal to n, okay? So while this number A is not equal to 0, what I'll do is, I'll access the last digit. So let's go with B. B is equal to A mod 10. Okay. S is equal to S times 10 plus B. And then I do B equal to B /10. Okay. So what did I do over here? So let's take a very simple example and understand why is this part actually reversing the number. So let's say we are working with 1, 2, 3. So in the first step, I'm getting the last digit of the number, which is 3, right? S initial is 0, so 0 times 10 plus 3 is basically 3, right? So now the value of S is 3 and the value of B now becomes 12, right? In the next step, when I get 2, now when I multiply S with 10, I'll get 30 plus 2, so that's 32. So you can see that the last block 2, 3 has reversed into 32. Similarly, the last step, it will become 32 times 10 plus 1, so you'll get 3, 2, 1. So this is the code that reverses a number, right? And I mean, Python is a pretty advanced language. Even if you want, you can just use reverse, okay? Even reverse works. So you can convert it to a string, reverse it, and then get it back to an integer, right? But I'm going with the old school method of reversing a number based on this pure logic. Cool. So now once I've gotten, so this is the part which reverses it. Now once I've gotten the reverse of the number, if S is equal to n, okay? So this new reverse number is actually equal to the original number. I'll print that it is a palindrome, okay? Else I'll print it's not a palindrome. Got it? So we have checked whether it's a palindrome number or not. Now the next part is we want to check whether it's a perfect number or not. So what I'll do is I'll put a elif clause, checking if the choice is 2 or not. And if it's 2, I basically want to check whether the number is a perfect number or not. So that is comparatively easier to check. So for I in range, n basically, you can go with this. If n mod I is equal to 0, which means I is a divisor of this number. What do I want to do? I want to add this to S, okay? So S equal to S plus. Okay, I did not define a variable here. So let's go with a dummy variable. Let's go with F equal to 0. And let's go with F equal to F plus the divisor, okay? And after this, what happens? So coming outside the for loop, I want to check if the number is equal to the sum of the divisors, except the number itself, okay? So if F is equal to n, I want to print, okay, I'll just copy this. Yeah, let's go with this. So you print it's perfect. If not, you'll print it's not perfect. Okay. Now there is a chance in which the user inputs something that's not one of these. So I just want to print a message saying that print wrong choice. Okay. Cool. So this is the code. Let's run this and see what happens. So the first input that we're giving is our number, right? So let's go with a palindrome number and let's enter 1 to check whether it's palindrome or not. Okay. So as you can see, we did not get the output. Why did I not get that? If you look over here in the statement, I went for B /10, okay, even though my number is actually A, okay. So this should have been a equal to a double slash 10. Okay. So decoding is a very integral part of coding. Okay. You need to be able to decode, or debug your own code. Okay. Let's run this again. So let's go with a palindrome 1, 2, 3, 2, 1. Let's enter choice 1. As you can see, it's palindrome, right? Let's check for a non-palindrome number as well. 1, 2, 3, 4. If I enter 1, you can see it's not a palindrome. Cool. So the palindrome part works. Okay. Let's go with 6. Okay. I don't really know any other perfect numbers. Let's go with 6. Enter 2. Okay. So if n mod I equal to 0, integer modulo by 0. Okay. So as you can see, this starts off with, okay, this is one more thing you should have changed. So I in range n, it starts from 0 to n minus 1, right? But you can't really divide a number by 0. So we should have started from 1 till n, okay? So you run this again, enter 6, enter your choice 2, and you can see it's a perfect number, okay? So as you can see, like in case you make a mistake while coding, just like I did, you can also just look at the messages given to you by Python. And in general, like whenever Python gives you an error, it's pretty simple to understand, okay? So accordingly, you can make changes in your code, all right? So this is question 4. Coming to question 5, a tech number has an even number of digits. If the number is split into two halves, then the sum of the squares of these halves is equal to the number itself. For example, if you have 1, 2, 3, 4, then 1, 2 is one half, 3, 4 is the other half. You want 1, 2 plus 3, 4 whole square to be equal to the number itself. So let's start off by inputting our numbers. So n is equal to input. So I want to give a message. So enter a number with even number of digits, please. Enter a number with an even number of digits. Yeah. Right, now what I want to do is, I want to extract the length of this number, right, because that's how we'll divide it into two equal halves. So directly let's do it in terms of strings. So let's go with d equal to number of digits equal to length of this. And then in the next step, what I'll do is I'll convert this to a integer, right? So n is equal to int of n. So if you want, instead of, if it's a number, then finding the number of digits is not really hard, right? We'll use the same idea what we use for reversing, except we'll not multiply it, okay? Every time we get a digit, we're just going to add 1 to some dummy variable. And at the end of the loop, whatever is the value of the dummy variable is the number of digits in the number, right? So we get this, okay? D equal to length of n is equal to int n. What I want to do is I want to split this into two equal halves. So for that, I'll write a code. Let's write the code first and then I'll explain what happens. So a equal to n mod, let's go with pow 10 comma d by 2. Okay, so what does this do? So for example, if you take 1, 2, 3, 4, to extract the last two digits of the second block, what I want to do is it's modulo 10 to the power the half of the number of digits in the number, right? So in this case, it's 10 square because the number has 4 digits. So the second half comes from the number modulo 10 square, and the first half will come from the number double slash 10 to the power half the digits, right? So this a basically gives you the last block, and if I copy this and if I write b, what I'll do is I'll just change this mod to double slash, right? This will give me the two individual blocks. Now I want to check if n is equal to power of a plus b comma 2, okay? This is basically a plus b whole squared. So if this is true, then we can print that it's a tech number, right? Right? And if not, I can basically print that it's not. Not a tech number, okay? So let's run this quickly. I think 2025 is an example of a tech number. So it is a tech number, right? Let's go with something else. 1, 2, 3, 4. It's not a tech number. I think 3035 is also a tech number. Right, let's Google for examples of a few more tech numbers. Yeah, 3025 is also 2025 and 3025 is also a tech number. 3025, so it is a tech number, okay? So it's as simple as that, okay? So in this case, dividing into two blocks was the tricky part. Apart from that, it was very straightforward. So these are some examples. We'll come up with more videos like this where we'll give you more questions to practice, okay? So if you like this video, stay tuned for more such content.